chemistry behind bread making.
Flour is the first ingredient and contains high levels of glutenin and gliadin, which are proteins that are together referred to as gluten and have a large number of amino acids. It is this elastic gluten network that stretches to contain the CO2 pockets when rising. Water is a solvent and dispersing agent for salt, sugar, and yeast. It is responsible for the consistency of the bread dough and is necessary for yeast fermentation and reproduction. Yeast is a single-celled microorganism in the fungus kingdom and is used as a leavening agent for the bread. It uses the sugars and oxygen in the dough to produce more yeast cells and CO2 gas, allowing the dough to rise. Salt is here for taste and essential for creating a strong dough because it tightens the gluten structure, giving it strength, enabling the dough to hold CO2, which is released into the dough as a byproduct of yeast fermentation. First, we need to mix the flour and water in order to have an autolyse. The flour absorbs the water, becoming fully hydrated. This activates enzymes in the flour that stimulate the proteins to form a network and start gluten development. We should let this mixture rest for about half an hour. After we add the salt. Salt is present in all bread not only because it gives flavor to the dough, but also because the presence of sodium and chloride ions are essential for the coming together of the protein chains, contributing to a stronger and more elastic dough. After we add the yeast. The yeast needs sugar to feed on, and luckily the hydrated flour contains the enzyme amylase, which is necessary to break starch down into simple sugar. In simpler terms, the starch becomes maltose because of the enzyme amylase. The sugars continue to break down even more and go from being maltose to glucose, which is a much more common term. Kneading comes next. When the dough is kneaded, the hydrated flexible proteins are stretched, create gluten strands, and incorporate air into the dough. This also helps mix things together as well, so the yeast finds new starches to feed on. Fermentation is after, and this is when we let the dough rest and rise. During fermentation, the bacteria in the yeast consume the glucose that was decomposed from the autolyse. The yeast consumes the sugars and releases CO2 and ethanol. This is what forms the tiny air bubbles that cause the dough to rise. It is trapped CO2 inside the flexible dough. Once the dough has risen from the trapped CO2, it is time to bake. Lastly, it is time to bake. Baking gives the dough a brown color, which is from a chemical reaction. When the dough is under a high temperature, such as 400 degrees Fahrenheit, a chemical reaction occurs on the surface between amino acids and sugar. This is called the Maillard reaction. Temperature plays an important role in the baking process because when the temperature increases, the yeast consumes starch and sugar faster and also produces CO2 faster as well. This is what causes the dough to rise in the oven, but eventually the yeast die and halt the rising process of the dough. This causes the air pockets to set and gives the bread the pillowy texture and light taste. Once this has occurred, you are ready to take your bread out of the oven and enjoy.
And there you have it, a freshly made loaf of bread. Thanks for watching!